Hi guys, today we are going to see how to clone the EDK2 source and its build process. Okay, so first thing what we are going to do is we'll open the Chrome and then we'll search for just EDK2 in the Google, and it will take us to github.com/tianocore/EDK2. So Tianocore is an open source project by Intel, and EDK2 is reference implementation of the UEFI. Okay, so how we can clone? So either we can use this code and then we can copy this URL and we can use this git clone and then followed by the GitHub URL, or go to the end of the page. There we can see this one. So to get a full buildable EDK2 repository, so we have to follow these commands. So I will copy this command, and here I will go to my downloads folder. So here I have already cloned the source. So let's open the new terminal, paste the commands, and it will start cloning. Okay, so meanwhile it clones, so we have already cloned one. Okay, so to build this EDK2 source, what and all the softwares are needed? So first thing what we need is the NASM compiler. So in this C drive slash NASM, so here I have my nasm.exe. What is the version of that? So in my case it is 2.16.01. Okay, and we need the Visual Studio. So if I open my Visual Studio installer, click on modify. Okay, so as you can see, I have installed this desktop development with C++ and the universal Windows platform development. So you can pause the video if needed to look at the individual packages which I have installed. Okay, so then if your NASM compiler is installed in a different directory, so then you have to create one environment variable. So the environment variable is name is, we can look into it. So we can go to this EDK2 demo. I will open this Visual Studio code in this directory. Okay, so I will simply search for nasm.exe, and here we can see the environment variable name is nasm underscore prefix. Okay, so how you can set it? So search for edit environment variable and then environment variables. Click on new environment variable name, which is nasm underscore prefix, and the path. This is needed if and only if your NASM compiler is installed in a different directory rather than c/nasm. Okay, so now so what type of which version of the Visual Studio it is going to support? As we can see, so if I go to the source, there is a file called edksetup.bat. Okay, so under this here we can see it supports Visual Studio 2012, 13, 15, 17, 19. In my case, I'm using this VS 2019. Okay, so since I'm using the Windows operating system, which is Windows 11, so I'm using this bat script. So if you're working on a Linux environment, so then you can use this edksetup.bat. Okay, so now, so here it takes some bunch of arguments. So in my case, it might be a reconfig or a rebuild or a force rebuild. So in my case, this is a first time freshly cloned source and the first time which I'm building, so I can use this force rebuild command. Okay, so what I'm going to do, so I will open this command prompt. Okay, then so let me increase the font. Okay, so edk setup.bat and then followed by force rebuild. I will hit enter. Okay, so meanwhile, let me make this split screen. So here you can see base tools, bin directory. So make sure you will have this Win32 folder get created. So if there is no Win32 folder get created after that force rebuild, so there is something wrong. Okay, so what this Win32 folder contains? So this Win32 folder contains the executable files which is needed during the build time. Okay, and the other file what we have to look is there is a folder called conf, and this target.txt file got generated. Okay, So what this target.txt contains, this one. Okay, so this file contains the active platform, the DSC file which we are compiling, and the target, whether it's a debug or the release, and then the architecture, it is by default set to i32, and the toolchain is set to 2015. So in my case, I'm using 2019, so I'm going to rename this to 2019. Okay, and here it has some bunch of build rules by default, so let's not play around those now. Okay, so now in the same command prompt, so I will use a command called build. Okay, I will hit enter. So here we can see the architecture is set to i32, target debug toolchain vs 2019. Okay, and parallelly here we can see there is a build folder got generated. So let me maximize this as well. So here we got this build folder. So within this build folders, we can see FV and i32. Okay, so let me go back to this build folder, and here we can see we have this i32 folder and then this FE folders. So what this i32 folder contains? So currently we are building this board emulator package.dsc file in a i32 environment. So here we have this i32, and here the UEFI drivers which is getting generated. Okay, so these are the UEFI drivers. Okay, so you can see the file format as the EFI, which is nothing but an UEFI driver. Okay, and if I go back to this FE folder, so meanwhile, let me open this one, right? Yeah. So if I go to this FE folder, so this FE folder contains the firmware volume and the BIOS binary. Okay. So here you can see, so here we have this firmware volume and this is our BIOS binary, which is an FD file. Okay. So now here I will go to this i32 and then here we have this WinHost. Okay, so we'll come to this WinHost later. So currently the emulator i32, right? So if I want to build this module in x64 environment, how I can do that? So again, same build command, but -a, which is an architecture. I'm going to specify x64 and I will hit enter. Okay. So meanwhile, it happens. We can go to, yeah, so here you can see it is got generated. So meanwhile, we'll go to this i32 folder, debug, i32, and then at the end, we have this WinHost. Okay. So if I double click on this WinHost, you can see the BIOS serial logs are coming, and here you can see the startup screen is coming. Okay, let's wait. Yeah, so as you can see, it is already booted to UEFI shell. So let me run the mmap command. Here I can type the dir command, and I can go to fs0 file systems, and then here I can do the dir, right? So here you can see we can run the EFI drivers from here, and then I will go to the exit, right? And here I can play around the setup knobs, right? So now if I wanted to store this serial console logs in some text file, how can I do that? Okay, so to do that, I will close this one, and then again I will open the fresh command prompt in the same directory. WinHost, I will redirect to boot.log. Okay, so now pop-up screen came up. Okay, so it booted to UEFI shell. I will close this. So now here we have this boot.log. So let me open this in the Visual Studio Code. So here we can see, let me minimize a bit. Yeah, so here you can see it is not complete BIOS serial logs, right? So to get that, again, I will open this same command prompt, WinHost redirected to boot.log, and then I will use this 2 greater than ampersand 1. Okay, so now the pop-up screen came, and here there is nothing came here, right? So now here it is booted to UEFI shell version 2.2, and then here you can see the boot.log contains all the serial console logs, right? So now let me, yeah, so here this x64 build is also completed. So now I will close this. I will go to this build x64 and then 19 x64, and then here also we have this winhost.exe. I will run the same. This is same exact behavior how we used to run the IO32 same as x64. There is no difference. It's just an architecture change. From the boot process or the build process, only the architecture is different, nothing else. Okay. So what we have gone through today. So we cloned the EDK2 source. We built the emulator package in both IS32 environment and the x64 environment. And we have stored the serial console output in a text file. And we have gone through what and all the softwares is needed for the EDK2 build process. Okay, that's it for today. Thank you.